All right, let's look at a problem with a dragster and pressure. So here we have a dragster. Let's draw this out. So we've got this dragster, and it says it has an internal diameter of 2.1 centimeters. There's our dragster. And we put in 30 psi, and the dragster is 73 grams. And we want to know what the acceleration of this dragster is. So, what formula we're going to use? We're going to use our pressure equals force over area, but we want an acceleration, so we need to make sure that it's force equals the pressure times the area. And we need to look at our forces then. So our sum of the forces, if we look at this, is just because we have no friction, so it's just going to be the force of the air. And that's going to be our net force, which is going to be the mass times the acceleration. So if we can find this force of the air, that's this one using our pressure, then we can get our acceleration, right? So let's look at this and see what we can do. We need the pressure and we need the area. So the pressure we know is 30 psi. Remember, that's 30 pounds per square inch. Okay, so in order to get the pressure, we got it right there, but we need to do a conversion on it because we need the acceleration, right? And this is in the metric system and that's in the metric system. So let's convert our pressure into the metric system. So when we do our conversion, we do our line conversion. So we put 30 pounds per inch squared here. Okay, and then what are our conversions? Well, I can look up and I can know that when I look it up, I know that 1 pound is 4.45 newtons, because that's what we want. We want it in newtons per meter squared. That's our Pascal. So then I also know that 1 inch squared is 6.45 centimeters squared. And I know that in 1 meter squared, there are 10,000 square centimeters. So let's put those in and see how we do. So pounds are going to go on the bottom. So 1 pound, 4.45 newtons. That means our pounds are going to cancel, right? Leaves us with newtons. That's what we want over here. So that's good. So now our inches. So our next conversion, 1 inch squared goes on top and 6.45 centimeters goes on the bottom. That's centimeters squared. So that's going to get rid of our inches for us. We're in centimeters, but now we need to go to meters, right? So the 10,000 centimeters squared goes on the top. And 1 meter squared goes on the bottom. So that gets rid of those. And so now we have newtons per meter squared, which is what we wanted. So we multiply by everything on top, divide by everything on the bottom, and we get 206,976 newtons per meter squared. So that's our pressure. So our pressure in the metric system in newtons per meter squared is 206,976 newtons per meter squared, right? So now what else do we need? So that's our pressure. Now we need our area. So what area is this? What area are we going to use here to calculate this? Well, if we look at our dragster, remember we have a cap inside here. And so when the pressure comes in and pushes, the only place it's pushing that causes the dragster to go forward, to move, is that cap. All these others, the pressure fills the whole tube, right? So we have all this pressure pushing on the outside. But this one and this one, let's just look at those for instance. If we have an area here and an area here, those generate the same forces. So those forces cancel. So the only place we're going to get a force that will push the dragster forward is from that cap. It's from the area of the cap. So it's just the area of a circle, right? So we need to calculate the area of the circle. So that formula is A equals pi r squared. And we know that our diameter, if you go back up, what was that? That was 2.1 centimeters. Equals 2.1 centimeters. So that means our radius is half of our diameter, which means it's 1.05 centimeters. But we don't want it in centimeters, right? Because our pressure is in meters squared, right? So we need it all in meters. So that means we move the decimal 2 places, so that's 0.0105 meters. So now we can calculate our area, can't we? We can come and say that the area equals pi r squared, which is pi times 0.0105 meters squared, right? And so when we do that, that says 3.463, and we'll carry a lot of these out. 3.463 6059 times 10 to the negative 4th meter squared. Now we won't use all of those, but we'll round that off later. Just writing all those out now. So there's our area. So now we go back and we say that the force equals the pressure times the area. And our pressure was 206,976 newtons times 3.4636059 times 10 to the negative 4th meter squared. Let's get some more space here. And so that says our force now, the force of the air, remember that's what that is, that's the air pressure, is 71.688 newtons. Okay? So there's our force. Well, that's not what we needed, right? We said we wanted to know the acceleration of the dragster. So we said we needed Newton's second law. Force equals mass times the acceleration. The acceleration equals the force divided by the mass. So that's 71.688 newtons divided by the mass. And if we go, let's go back up and look. Where was our mass? Oh, right here, 73 grams. 73 grams. But that's not what we needed it, right? Because remember, a Newton is a kilogram meter per second squared. So we got to change that to kilograms. So we say our force is 71, nope, sorry, we're doing the acceleration. Looked up above. So the acceleration is our force, 71.688 newtons divided by point, and remember, there's our decimal, so we move it 3 places, 0.73 kilograms. So when we divide that, we get 982.03, and remember, our Newton is a kilogram meter per second squared, so the kilograms cancel, and that leaves us meters per second squared, which is an acceleration. So that dragster would have an acceleration of 982.03 meters per second squared.